Today, I will present an empirical analysis examining how pricing decisions affect profit per capita at TabletCo. Using panel data across regions and time, I estimate how changes in price influence profitability while carefully controlling for regional and time specific effects. The objective is to determine whether raising or lowering price would improve firm performance. The core research question is what will happen to profit per capita if TabletCo raises or lowers its price? From an economic perspective, we test whether price has a statistically significant impact on profitability. The null hypothesis states that the price coefficient equals zero, meaning price has no effect on profit per capita. The alternative hypothesis states that price does have a statistically significant effect. This hypothesis test allows us to move from intuition to statistical evidence. I assume that profit per capita is generated by several factors. First, price, which is the main variable of interest. Second, socioeconomic and demographic characteristics such as income, education, population, unemployment, rainfall, and household size. Third, region-specific effects, capturing permanent differences across regions such as competitive intensity and cost structure. Fourth, month-specific effects, capturing seasonality and macroeconomic trends. This framework allows us to isolate the causal effect of price while controlling for confounding factors. The dataset is panel data, meaning it follows multiple regions over multiple time periods. Panel data is powerful because it allows us to exploit within region variation over time, control for unobserved time invariant regional differences, and control for month-specific shocks. Including region-fixed effects ensures that permanent differences between regions do not bias or estimate of price. Including month-fixed effects controls for seasonality, macroeconomic conditions, and nationwide shocks that affect all regions simultaneously. Together, this produces a two-way fixed effects model, which is the appropriate framework for this setting. This model is estimated using ordinary least squares. I implement a two-way fixed effects regression controlling for both region and month. Standard errors are clustered by region. Clustering is important because observations within the same region over time may be correlated. If we did not cluster, we would underestimate standard errors and potentially overstate statistical significance. Clustering ensures valid statistical inference. The analysis was conducted using Python in a Google Colab environment. I used the stats models package to estimate the OLS regression. Fixed effects were implemented using categorical indicators for region and month. Clustered standard errors were computed at the regional level. The workflow included data cleaning, variable preparation, regression estimation, and graphical analysis. The key coefficient of interest is the price coefficient. The estimated coefficient or point estimate is approximately 0.0077. This means that a $1 increase in price increases profit per capita by about 0.0077 units, holding all other variables constant. The coefficient is statistically significant at conventional levels with a p-value below 0.01. Importantly, this result holds even after controlling for region and month fixed effects. This suggests that the relationship is not driven by time trends or regional differences. Several control variables also show meaningful effects. Average income has a positive and statistically significant impact on profit per capita, suggesting higher income regions generate greater profitability. Unemployment has a negative and statistically significant effect consistent with reduced purchasing power in weaker labor markets. Other controls are not statistically significant once fixed effects are included. The overall R-squared is high, which is expected in fixed effects models because region and month dummies explain substantial variation. Using the estimated coefficient, we can simulate pricing change. A $10 increase in price is predicted to increase profit per capita by approximately 0.077. A 10% price increase results in an estimated increase of about 0.59 units in profit per capita. Because the coefficient is positive and statistically significant, the model predicts that moderate price increases will increase profitability. Similarly, price reductions would decrease profit per capita. These predictions are linear and supported by the confidence interval analysis. The p-value measures the probability of observing a coefficient as extreme as ours if the true effect were actually zero. A small p-value, such as below 0.05, means we reject the null hypothesis. In this case, the p-value for price is well below 0.01. This indicates strong statistical evidence that price affects profit per capita. It does not measure economic magnitude, it measures statistical certainty. The 95% confidence interval provides a range of plausible values for the true price effect. In this case, the interval is approximately 0.0038 to 0.0116. This means we are 95% confident that the true effect of a $1 price increase lies within that range. Because the entire interval is positive, this reinforces that the price effect is statistically significant and economically meaningful. The results suggest that after controlling for regional heterogeneity and time effects, price increases are associated with higher profit per capita. However, it is important to acknowledge potential endogeneity concerns, such as whether pricing decisions respond to expected demand change. Overall, the evidence supports the conclusion that price adjustments can materially affect profitability. Thank you very much.